Let's discuss the question number 27. This is from test 3 and the topic is engineering mechanics. Okay, so a small block of M is sliding on a rough horizontal surface with a velocity v0. Okay, and this is rough surface, so the kinetic friction coefficient will be there and it's not given. Okay, so what there, it will be some positive value. Okay, and if the velocity, what it says is if the velocity is reduced to v0 by 2 in 30 meters. Okay, so this is position 1, let's say this is position 2, and in 30 meters the block will come to rest in the next meters. How many? So in next how many meters the block will come to rest? So this becomes 0 in next how many meters? So that is what is asked. So let that be x, because and velocity is 0. So let this be position 3. So let's do this by energy methods, because velocity is given. I mean, you can do a force acceleration method also. Okay, but then again you have to prove that acceleration is constant or not. But let's do it in a simple way. Position method between position 1 and 2. Okay, so position 1 and 2. So because so the energy at position 1 is the kinetic energy half v0 square, and now that is equal to the kinetic energy at position 2 plus some energy has gone into the friction. So if you consider the free body diagram of this, the friction will act in this way and this thing is moving in this way. So the work done by the friction, work done against friction. Okay, so this is basically the kinetic energy at the start, position 1, and this is the kinetic energy at the position 2, and the difference is basically the work done against friction. Work done against friction. Okay, so so that can be, because the friction force is basically, if you take this as mg and this as n, so these are the forces and the friction is F. So the friction force is given by mu into n, and n, because n is equal to mg here if you consider the static equilibrium. So work done against friction will be mu into mg into the distance traveled s. So this becomes half mv0 square plus half mv0 square by 4 plus mu mg into 30. Okay, so this I can just write down as 3 by 4 into half m v0 square, okay, is equal to mu mg into 30. So this is equation 1. Now it is now, because the velocity is reduced, now if you let the block travel furthermore but in distance x, it will come somewhere it will come to rest. So we are supposed to find out where it comes to rest. So now let's apply the same principle from 1 to 3. So the kinetic energy, because now we have not considered the potential energy here, because everything is the action is happening only on the horizontal plane and the potential energy remains unchanged. So you have the kinetic energy at position 1 is equal to kinetic energy at position 3 plus the work done against friction. Okay, so while writing out the work done against friction, always remember how much is the distance traveled. Okay, so ke1 is basically half mv0 square. Now ke3, it comes to rest, so when the velocity is 0, ke3 is 0, and the work done against friction is mu into mg is the force, and what is the distance travel? So distance travel here is s plus x, so that is nothing but mu mg 30 plus x. So we are supposed to find out how much is x. Okay, so this is 2. Now as mu is unknown and I need to find out x, so let's divide 1 by 2. So I get 3 by 4. So 3 by 4 will be basically equal to 30 by 30 plus x. So this gives rise to x as 10 meters. So the answer is A. Thank you.